do that. Okay. So here we go. Thank you again for hanging on and just being patient with me. Sometimes the tech doesn't work exactly like it should. All right, so here we go. We're wanting to plot this. The first thing I want to do is I want to make a table of values. I'm going to put my x on this side, my y on this side, so that I have an x comma y to plot on my graph. Now this is the part you get to choose. What are your x values? Probably the easiest ones for something simple like this is to choose 0 for sure, because 0 is often the easiest math. 1 and 2. Why not? Okay, and then if x is 0, so I'm going to replace x with 0. What is y? Well, y is equal to minus 2 times, instead of x, I'm replacing it with my x value, which is 0, minus 3. So this is going to be minus 2 times 0 is 0 minus 3. So it's going to be negative 3. Now, if x is 1, I'm going to try this out. I'm going to replace the x in the equation with 1 right here. So this is negative 2 times 1, which is negative 2, minus another 3 gives me minus 5. Now, at this point, here we go, I see a trend, and I bet you this is going to be minus 7. If you see that and it's going to be off the graph, it isn't going to be off this grid, but if it is, then you can change your gears and say, okay, well, I want a minus 1 then, or I want a minus 3 or something like that, and that'll turn around in more of a positive direction. I'm just going to double check to make sure this is. So if x is 2, what is y? So I'm going to replace the x value here with the 2. So negative 2 times 2 minus 3. Negative 2 times 2 is negative 4. Minus 3 is negative 7. Hey, it is minus 7. And like I said, if you are in sequence, like I'm increasing by 1 here, it's probably going to increase by the same amount on this side too. And it increases by 2, which is what this number here actually tells us, the slope of the line. So I could use these, or I could say, okay, I want to find out what's on the opposite side. So let's do a negative 2. Because it's getting too far down. The y direction is too far down. It's only this far, so we have a little bit of space still, but minus 2 times negative 2 minus 3. Negative 2 times negative 2 gives us positive 4 minus 3, which is a 1. Okay, and the last thing we're going to do now, we're on the home stretch, is we're going to plot these. So I'm going to plot 0, comma, minus 3. 0 in the x direction, so it's here, and a minus 3. 1, 2, 3. There's the 0, comma 3. Let's plot this. When x is 1, y is minus 5. When x is 2, so I can do these, I can put little brackets around these, that's fine too. When x is 1, 2, 5, 6, 7. Or I could do this one, minus 2, negative 2, comma 1. So x is negative 2, negative 1, negative 2, and a positive 1. And if I connect these up, oops. I just want to make sure that this is, yeah, that's pretty close right here. What these allow you to do is, if you don't want to calculate, you know, what's at minus 6, you can sort of just guess, oh, minus 6, comma, 5, 6, 7, 8, 9. Minus 6, oops, that wasn't what I wanted to do. Negative 6, comma, positive 9. And I'm guessing if I fit this in there, it would actually fit. That's called extrapolation. Interpolation is when it's between your points, and extrapolation is when it's beyond your points. So I could, if I wanted to, and zoom right out, be able to say, okay, what is it going to be when x is 100? Well, it's probably easier just to put it in the equation, but you could do that with the graph. All right, number 2. Here we go. I'm going to start with table of values. We do 0, 1, 2. because those are usually the easiest numbers, I'm going to just replace my x into the to find out what y is into the equation. So 3 times 0 plus 5 equals 0 plus 5, which is 5. What if x is 1? Well, then I'm just going to replace the x with 1. I hope that it's not my Wi-Fi that's being glitchy. Plus 5 equals 8. And lastly, here we have 3 times 2 plus 5. We have 6 plus 5 is equal to 11. Now, if your Wi-Fi is really totally lagging here, these will be on the recording. I'm recording this right now, so you can watch it. It's just way better if you could just do it right now. We have 0, 5. So 0 is in the x direction and positive 5 up here. In our x direction, we have 1. And our y direction, we have 6, 7, 8. Now this is too far, so you know what? I could plot this one and just sort of make it up. 2, 11. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to be somewhere around here. Or I could choose I could choose a -5 because I think that's going to be, it's going to land somewhere down here, guessing where my line is. So I'm just going to do this as fun. Plus 5. 3 times -5 is -15 plus 5 gives us -10. Wow, that doesn't really make sense, does it? That's what it says, -5. It might be way down here. We'll see. -5, comma, -10. Let's see if that actually works. Oh, and it does. Look at that. Pretty close anyways. I haven't drawn my, that one was obviously out, but if I draw this one, there we go. Typically, we're going to put in arrows on these, which I haven't done. That means that it goes on forever. It goes right up to infinity. You can figure it out. If this was, for instance, oh, I don't know, this graph was describing how many shots per minute, how many baskets per minute you can make. Well, you can't make an infinite amount of baskets. There's got to be a limit to it. And so you wouldn't put the arrow because it wouldn't continue on. And likewise, if this was like number of people who've eaten a chocolate bar this last day, you wouldn't put a straight, a full line because it wouldn't have 3.5 people. You would have dots on the people. So it would be just a dotted line because you can't have half a person. All right. Here's 2 of them that you're going to want to also look for. These are weird looking graphs, but I'm going to show you how easy they are. You don't have to remember them, but you have to know how to figure them out really quickly. So y is equal to 1. So I'm going to draw my table of values with my x and my y. I'm going to give my x a bunch of numbers, 0, 1, 2, 3. I'm just going to put a bunch of them in there because it doesn't matter. So when x is 0, well, y is equal to 1. Okay. When x is 1, doesn't really affect it. Y is still 1. When x is 2, y is still 1. It doesn't matter what x is. Y is always 1. So if we plot these, my 0, 1, or 1, 1, or 2, 1, 0, 1, or 1, 1, or 2, 1, or 3, 1, or 5, 1, or 10, 1, what you'll see is that this is a horizontal line. And it'll just go on forever. It could be infinity. X is infinity. Y is still going to be 1. So it just keeps going in this direction. All right. I might just change my color here momentarily. How about this one? This looks like similar but different. So I'm going to draw my table of values here. Here you can't say, well, what happens if x is equal to 0? Because x is already -3, but if y is 0 or 1 or 2 or 3 or 4, x is always going to be -3. So if we plot those, so x is -1, -2, -3, comma 0, -3, comma 1, -3, comma 2, and 3, and 4, and 5, and 10, and -10. If you plot those, this is going to be a vertical line. So just so you've seen these, this is how they look. They are straight lines, so we have to cover them. When x is -3, I always think, okay, x is -3 no matter what y is. So no matter what y is, x is -3. Same as here. Y is always 1. Y is 1 no matter what x is. So you can put dots the whole way along. Okay, do you guys have any questions about graphing? Because I think that's it. And then we're going to move into algebra here. Okay. Let's move to the graphing here. There's a whole bunch of these. What I do want to do before we start on any of these is give you sort of a quick primer on graphing or on algebra, sorry. Only because some of you guys might not have remembered what you guys did last year or you missed out, or whatever it is. It doesn't take very long. Algebra is awesome because there's really simple, clear rules to follow. So the way that I do it is I imagine that there's two separate sides split by an equal sign. So if it is 2x is equal to 4, my equal sign is going to be divide the two sides. It's like a soccer match. We have one side and we have the other. The whole point in algebra is to find out what one single positive variable, like an x, is all by itself on one side of the equals. So the whole point is, like on this sort of thing, is to have one x on one side of the equals and everything else, probably mostly numbers, on the other side. And I'll show you that again. So the whole point is to have x is equal to whatever this is. You can combine like terms. So like terms are all like x terms, or they're all like numbers. You can't combine what is 5x plus 2. You can't add them, but you can say, hey, 5x and 2x is 7x, and 7x minus 6x is 1x. Likewise, you can say, you can't say 10 minus 6x. It doesn't work like that. But if you say 10 minus 4, oh, well, that's 6. And 6 plus 2 is 8. So you can combine like terms. And if you have x and an x squared, they don't mix. It has to be like x to the 1 power and x to the 2 power. That's a little bit beyond where we need to go today. You probably won't run into these, but you combine like terms, and this simplifies it. And this is essentially what we're going to be doing, is just simplifying, pulling it apart and simplifying and combining like terms until we get what we actually want. We have one x on one side of the equals, and that's exactly what we want. This is exactly the same. 1 times x, or x is equal to 8. And we could substitute 8 in here, and 8 in here, and 8 in here, and it would work out that both sides are equal. And I'll show you that too. All right, Here's one of the biggest rules that I have in algebra. As long as you remember this, it makes it go way better. Whatever you do to one side of the equals, you have to do to the other. Okay, so I'm going to show you some examples. Here's my two sides of the equals. I want x all by itself on one side. I don't want this plus 3 on this side. I just want to get rid of it. So what's the opposite of adding a 3? It's subtracting a 3. But if I do this to one side, I have to do it to the other. So now I have x, I have plus 3 minus 3. Those turn to 0, so I could say plus 0, or I can just leave it out, because these cancel each other out, right? But I have to do it on this side. 10 minus 3 is 7. And that's how you do these questions. So you look and say, okay, how do I get rid of it from one side? I'm going to do the opposite of how it's connected to the x. And then I have to do it to the other side. I'm going to show you we're going to do a bunch of these examples. I just want to do this as a primer here. I've got one of the basics for each of these. Here's my equals, so it divides the two sides. I just want x all by itself. This thing is getting in the way. It's got to get out of that side. So it's a negative 9 or a subtract 9. What's the opposite of subtracting 9? It's going to be adding 9. So I'm going to add 9 to one side. I have to do it to the other. Negative 9 plus 9 is 0. So it just leaves me with x on this side. This guy comes right down. These are 0, so we can cancel those out. But we have 2 plus 9, which is 11 on this side. And if we substitute back in, 11 minus 9 is equal to 2, and 2 is equal to 2. Perfect, the same here. 7 plus 3 is 10. 10 does equal to 10. So we know that it works. Here, I just want to make sure that you guys understand these two, and then we will just get to some questions here. Here we have 4 multiplied by x. We have 4 times x is 16. We just want to know what one positive x variable is. So what's the opposite of multiplying by 4? It's divide by 4. But I don't want to write the divide sign. I'm just going to do it like the fractions. Divide by 4 and divide by 4. So if I divide one side by 4, I have to divide the other side by 4, no matter what. 4 divided by 4 gives me 1, right? Or 1x. And 16 divided by 4 gives me 4. And that would be my answer. Oh, and this one didn't work out. It was supposed to be, let's say it's the 2x. No, this is supposed to be x divided by 2 is equal to 10. I think I put something in here. If possible, get rid of the fractions early on. And that's what I'm going to do. I don't like the fractions. But I'll show you those examples in a few minutes too. I have x divided by 2 is equal to 10. What's the opposite of dividing by 2? It's going to multiply by 2. So 2x divided by 2, or 1x. And there's my equal sign. And 10 times 2 is 20. And it makes sense if I replace x with 20. 20 divided by 2 is 10. 10 does equal to 10. And of course, these are really easy to figure out in our heads because they're very simple examples. We're going to get much more complex where you can't really do them in your head. Here's something we looked at really we sort of looked at earlier last week, is if you have 2 times something in brackets, you have to multiply them through. So this means that you could have 2 times whatever's in the brackets, or you could have 2 times x and 2 times minus 4. And what I do is I always draw these little arrows to remind me that, okay, I have to multiply them all through. Super important skill to know. And especially when this is a negative, I think that we looked at that last week, that kept catching us. The negative would mean that it becomes negative 2 times x is negative 2x. Negative 2 times negative 4 gives us a positive 8. and then you would solve. And the last thing that I want to say is, if possible, get rid of fractions early on. I'm going to show you that while we're going through these examples. So without further ado, let's switch to page 3 here, and let's get motoring. Okay, so you'll know how to do a bunch of these already. I'm just going to talk through them. I want to get x all by itself. Here's my divide line. So I want to get rid of this plus 4 term. How do you do it? I'm going to subtract 4 from both sides. So now I have x, that's going to be a 0, is equal to 10 minus 4 is 6. Here we go. Here we go. X minus 9 is equal to 11. I want to get rid of this from this side of the equals. So I'm going to add 9. It's the opposite of subtract 9. Add 9 to both sides. And x is equal to 11 plus 9 is 20. All right. Here we go. We've got a multiply. So 5 times x is 15. We just want one x on one side of this equal sign. 5 times x, the opposite is to divide by 5. And if we do it to one side, we divide by 5 on the other. 5 divided by 5 is 1, or 1x. And 15 divided by 5 gives you 3. And if we plug 3 back in, 5 times 3 is 15. 15 does equal 15. Yeah, you were making it. Okay, here's one with 2 steps. So what I do is I always think of the subtract and the adding as a weaker bond or weaker link to the x. So I'm going to get rid of those first. I'm going to do all the numbers first, and then I'll do the multiplications and divisions at the end. So in this one, I have 2x minus 12 is equal to 4. Let's get rid of this minus 12 first. So I'm going to do that by adding 12 to both sides. Let me zoom in a little bit here. Hope you guys don't mind. So negative 12 plus 12 gives me 0. It sort of cancels out. So I'm left with 2x on this side is equal to 4 plus 12 is 16. Now I have 2 times x is equal to 16. I want to do the opposite of times 2, which is going to be 2 divide by 2. 2 divided by 2 just gives me 1, or 1x. 16 divided by 2 gives me 8. And apologies for not making really enough room here. Okay, and I want to make sure that you guys can see. So if you're scribbling down answers, you're still able to catch up here. All right. Here we have x divided by 7 equals 14. What's the opposite of divide by 7? The opposite of divide by 7 is times by 7. So we're going to times both sides by 7. So this could be 7x over 7 equals, oh boy, 70 and 28 is 98, I hope. 7 divided by 7 is 1, or just 1x is 98. I hope that's right. If it's not, you can tell me. 70 and 28, yeah. Seems right in my head anyways. Okay, this one, we have 2 different ways of doing it. I'm going to do it the first way, and I'm going to do it the fast way. We have 3 over 2x is equal to 9. Now we could get rid of the fraction right now, and the way to get rid of the fraction is to multiply by that 2, that bottom number. So we could say, let's times it by 2, and let's times by 2. So we would have 6x over 2 is equal to 18, or 3x is equal to 18, right? 6 divided by 2 is 3. Now we have 3 times x is equal to 18. We just want to know what 1x is, so we're going to divide by 3. And divide by 3 on the other side, because that's our rule for sure. It's one of the most important rules. So we have x is equal to 6. I said I'd show you the fast way. I'm not sure that's going to be any faster, but we can do it. 3 over 2x is equal to 9. I'm going to multiply by the reciprocal, which means the flipped variable, the flipped fraction. So I'm going to multiply by 2/3, and I'm going to multiply this by 2/3. This would be 6 over 6x, which gives me 6 over 6x, which is really 1x. And this is going to be 9 times 2 is 18 over 3, which is 6. Same way of doing it. And you can choose which way you're going to do it. I probably will do the simple way. I don't mind doing that extra step. But some people like to take the fast way going through this. All right, let's do this one here. Now, I want to just cover, I just want to go through here just for a second. Okay, I want to go back to this point. The whole point of algebra is to have a single positive variable all by itself on one side of the equals. Does it matter which side? No, it doesn't. So here, I'm going to do this 2 ways as well. I'm going to do it the way that probably is the easiest, but it is actually the hardest. Is I'm going to say, okay, I want to get rid of this 5. That's a positive 5, right? So how do I do that? I'm going to subtract 5 from both sides. So I have negative x is equal to 2. But I want to know what it is, one positive single. So I have to either multiply or divide by -1. And this is the hard part about doing it this way. Negative divided by negative, or negative, you could do multiply by 1 as well, but this is going to be x, and 2 divided by -1 gives me -2. And that makes sense. 5 minus -2, which is 5, plus 2, which is 7, is equal to 7. The other way that you could do this, and this is probably how you should probably start these, is you say, okay, I want to like put all the x's as positives. So what if I move this to the other side? What if I added x to both sides? I would still have 5 here. This comes down. These are 0. 7 plus x. It's no problem. We haven't broken any rules really. We're just moving the x. We're subtracting, or we're adding an x to both sides. Now we're going to subtract this 7 because we don't want this number here. We want to get it on the other side. So here we have x on this side. These cancel out. 5 minus 7 is -2. And it looks backwards, but this is the same thing. And the ability to move on either side will certainly eliminate having a negative or dividing by a negative, which is, in all honesty, is where you're going to make those little mistakes. Algebra isn't necessarily where you're going to lose your marks in all the little details, like the negatives and the positives, the adding, the subtracting, just the little mistakes that you can make. You have to be super detailed to do this really well. Okay, I hope that you guys can still see this. I'm going to move on to this one. I'm going to do it the other way. I want to get rid of this 3. And everything's divided by 3, so I'm going to multiply by 3, and I'm going to multiply this side by 3. I'm just going to put brackets around this just so you can tell what I'm doing. So this could be 6a over 3 equals 24. Or you could just cancel these and say this is 2a is equal to 24. You just cancel those out, and you're left with 2a is equal to 24. I'm going to divide by 2 for both sides. A is equal to 12. You could also multiply by, let's do this one, 2/3 a is equal to 8. I'm going to multiply by 3 over 2. The reciprocal, or the flip of this fraction. And I'm also going to multiply the same on both sides. This could be 6 over 6a, which is just a, and this is going to be 24 over 2, which is 12. Either way works. Some people like the systematic, let's just get rid of the 3. Okay, now let's deal with the 2. Some people say, no, let's just cut to the chase, let's go. And this way also works just great. Here's another problem that we're going to, the exact same thing. I'm going to do it 2 ways. I'm going to multiply by 5. So the 5s cancel out. I'm left with negative 4x. See, and this is why I don't like having the times, because it confuses, it looks like an x. So I'm going to use a dot. Some people use a dot, like 4 times x. That means 4x. This could be minus 20 over 5, which is negative 4x. And 5 times 12 is 60. Now I want just one positive x on one side. Oops, I don't want to divide by negative 4 on both sides. Negative 4s will cancel, the negatives will cancel, the 4 will cancel, just left with x. And this is going to be 15, but in a negative. I almost lost my point there. Negative 15. And of course, you could multiply by negative 5/4, and it would come out to the same thing. Just for brevity, I'm going to continue on because I'm slowly running out of time again. Here, I'm going to leave my x term, even with the fraction, I'm going to leave it alone until I get rid of this on this side. So I have 2/3 x. I'm going to add 14 to both sides. Negative 14 and positive 14 come out to 0, so those cancel out. Negative 10 plus 14, I have 4 more positives than those negatives, so I've got 4. Now I'm going to get rid of that 3 on the bottom by multiplying by 3 on the top. Instead of divide by 3, I'm going to multiply by 3. The 3's cancel out, so I have 2x is equal to 12. Now I have 2 times x. I want to divide by 2, so that's the opposite of a times. The 2's will cancel out. X is equal to 6. Okay, let's hope that we're getting there. Do we have, oh my goodness, we've got a couple more pages. We got to sort of motor on in order for me to even come close to finishing. So this is really where the grade 9 material starts. So here we go. Let's group like terms. These are like terms, and this is a different like term. So let's group those. 3 A's and 6 A's gives us 9 A's. Minus 27 or negative 27 plus 9 gives us negative 18, I hope. Now it's an easy question again. We have 9 times A, so we're going to divide by 9 because it's the opposite of a times by 9. And A is equal to negative 2. Okay, and here's where we get into the brackets. So we have negative 4 times whatever's in this bracket. So I'm going to draw my little arrows. This is where you can bring out your inner artist and draw not much nicer arrows than me. And so it means I have to multiply. This is 4 times whatever's in the brackets. So I'm going to do negative 4 times n gives me negative 4n. Negative 4 times negative 2 gives me a positive 8. It looks like that last question I just did. And this side doesn't change yet. Okay, now we're back to square one again, where we were on the first page. Let's get rid of this. The opposite of adding 8 is subtracting 8. So we have negative 4n. These are zeros, turns into 0. And 16 minus 8 gives us 8. Now I have a negative 4 times n, so I'm going to divide by negative 4. I might as well get rid of the negative at the same time. So n, this is positive. Negative divided by negative gives me a positive. 4 divided by 4 gives me a 1. 1n, or just n, is equal to 8 divided by negative 4. Positive divided by negative is a negative. 8 divided by 4 is 2. There we go. I just want to make sure I'm not missing any. Awesome. Okay, here's one that's a little bit more complicated, but it's not really. It's an extra step that you have to do. I'm going to draw I want to multiply my 3 through everything inside of the brackets. And I also want to, and what I'm going to do is you can even circle this with the sign. If there's no sign, it's assumed it's a positive. But here I'm going to circle the negative as well, because that's a reminder when I'm multiplying through to not forget the negative. The negative has to be multiplied through as well. So let's do this first part. 3 times 2x gives me 6x. 3 times 2 gives me plus 6. Okay, negative 4 times 3x. Negative, it's going to be a negative. 4 times 3 is 12, and there's just one x. Negative 4 times negative 1 gives us plus 4. Okay, here's where we have to make a decision. Do we move x's to the right or to the left? And I look to see which one has the most positives. This one has the most positives over here, so I want to get rid of these and and move them over, essentially. I just want to get rid of them on this side. I'm going to go with where I have the most positive x's. I'm going to do the x's first, and then I'll deal with the numbers next. It doesn't really matter. You can deal with the numbers first and the x's next, but I want to get rid of the minus 12 x's, so I'm going to add 12 x's to both sides. So I have 18x. The plus 6 is still on this side, and it won't be for long. This is going to be canceled to 0, and I just have 4 on this side. Now let's get rid of this thing. Move it off this side of the equals. So I'm going to subtract 6 on both sides, and I'm going to move it over to here. So we have 18x. This cancels out, and I have 4 minus 6. It's going to be negative 2. Okay. I have 18 times x, and I just want to know what 1x is. So instead of 18 times, it's going to be divide by 18. I'm going to divide by 18. So x is going to be negative 2/18. And if we simplify, which we usually do in these kind of things, is what can we divide both in top and bottom by? We can divide by 2 on the top and the bottom. So we have minus 1 over 9. So I'm going to type that in, or write that in there. X is equal to negative 1/9. I'm going to leave this up just so that whoever needs a hand, because the next one is a little bit trickier, and I'm going to explain how you do it. It's similar to the fractions, but not really. It's sort of similar, but a little bit different. Okay. With these, take a deep breath. We're going to get through this. It's no problem. We're going to look at the bottom numbers. And again, this is where in that last page here, I think it was in the very bottom, I said, if possible, get rid of the fractions early on. Fractions just make things a mess in here. So I want to get rid of this, and I want to get rid of this. I'd rather have a number that's just all on the top, not have to do with fractions. So what can I multiply both sides to get rid of the fractions? Well, I'm going to do my LCM trick, lowest common multiple trick. So I'm going to list 3 times 1, 3 times 2, 3 times 3, 3 times 4, and it goes on. I know what it is, so I'm not going to go any farther. And 4 times 1, 4 times 2, 4 times 3. There's the lowest number. So that's what I'm going to multiply both sides by. So I'm going to rewrite this. A minus 1 over 3 is equal to 3/4. I'm going to, in big brackets here, multiply by 12 times 12. Okay. So this is going to be, on the top, it's 12 times a minus 1 divided by 3. And this will make sense here in a second. 3 times 12 on the top over 4. Now I can cancel some of these. I know I can divide this by 3 and this by 3. You know, I can just cancel those, And I can also cancel, I can divide this by 4 and 4. 12 divided by 4 is 3, 4 divided by 4 is 1. So now really what I have is 4 times a minus 1 is equal to 3 times 3 is 9. I'm going to multiply this through. 4a minus 4 is equal to 9. Get rid of this one. I'm going faster, but I'm running out of time. I got 3 minutes to finish a page. So 4a is equal to 13. Divide by 4 because I don't want 4a, I just want 1a. And a is going to be 13/4. I'm going to also leave this up so that if you want to copy that one, and I'm going to finish this last one. The last page isn't that long, so I will not be that, we're not that far off of schedule. Here we go. We have a bunch of things with fractions or denominators. Let's get rid of them. The LCM 2, 4, 6, 8, 10, and 5, 10. 10 is the number that we're going to multiply both sides by, so it's times by 10 times by 10. Now, I put it in brackets because I want to multiply, I have to multiply everything through. I want both sides. And I'm going to multiply it through to each of these. So I have 10 times 1/2, or 10 halves x. We have 10 times 2/5, so it's minus 20 over 5. And here it's going to be 10 times 4 is 40/5. Now, the beauty now is that I can cancel these out. 10 divided by 2 is 5x. 20 divided by 5 is 4. And 40 divided by 5 is 8. This looks so much more reasonable. And that's the thing. That's why I keep thinking it's like algebra. You sort of have to pull it apart a little bit. And it's like, oh, okay. You know, when you get a bunch of ropes stuck in a knot, you don't just keep pulling. You have to untangle a little bit. And then it's like, oh, okay, I see how it has to go undo. This is what we're doing here. We're sort of untangling a little bit and simplifying it. And it's like, oh, okay, now it's easy to undo. So we're going to keep the x's on this side. Let's add 4 to both sides. We have 5x is equal to 12. I'm just going to write that over here. This is 5 times x. We want to do the opposite of 5 times, or times 5, which is divide by 5. So let's divide both sides by 5. 1 and 1. So now we have x is equal to 12 over 5. And it's totally fine to leave it as an improper fraction. In fact, that's probably the optimal answer right now. You could leave it as 2 2/5. But if you have to do any more stuff, you have to convert it back into improper. So it's probably fine to leave it as improper. 12/5. Okay, home stretch, you guys. And it's a really quick one because these ones go fast. Okay. A number of different ways you can do this. You can multiply 2/5 into each of these. I'm going to do it slightly differently. I'm going to look for the LCM right now. So it's 5, 10, 15, 20, and for 4, 8, 12, 16, 20. 20 is our number. So let's multiply. I'm just going to erase that because we've all seen it. It's just going to get in the way. So let's multiply both sides by times, oops, I'm just going to do times 20, just so it's not confusing. Okay, so now I want to, because this, I just have to multiply it through to this one. I don't have to do it to this one because if I do it to this, then I have to do it to that. Because 2/5 is already being multiplied into the bracket later, I can just multiply it this. Same as here, because 3/4 has to be multiplied into the bracket at some point, I can just say 20 times this fraction and it will eventually be multiplied into the brackets. So I'm just going to do that. So 20 times 20, that's 40 over 5, x plus 2. And this is 60 over 4, x minus 2. Okay, 40 divided by 5 is 8, x plus 2. And 60 divided by 4 is 15, x minus 2. Okay, and here's where we have to sort of do a little bit of work to simplify it and then to make it so that we can join these parts. So I'm going to multiply the 8 through the whole bracket. And this one I'm going to multiply the 15 through the whole bracket. So 8 times x is 8x. 8 times 2 is 16. 15 times x is 15x. And 15 times negative 2 is minus 30. Now on this one, I've got x's on both sides. Where do I have most positives? I'm just going to make my life easier. I could do it either way. I have more x's on this side. So I'm going to take the x's away from this side and move them all to here. And eventually I'll move all the numbers over there. Let me move this up a little bit. These will cancel to 0. So I have 16 is equal to 7x minus 30. Now I'm going to get rid of this. Get rid of that by adding 30 to both sides. So I have 46 is equal to 7x. Thank goodness we don't have to do this in our heads. We're 7 times x, so we have to divide by 7, and x is going to be 46 over 7, because these cancel out. So x is going to be 46 over 7. And I'm going to leave this up so that if you want to catch up and write, you can do that. The last two look like trick questions, but they're not. They're really easy, actually. Here, how did we get rid of the denominator, the number on the bottom of the fraction? We multiplied it by the LCM, but if you had 2/5 is equal to x, you would multiply by that same number to get rid of it on the bottom, right? You'd cancel out, you'd have 2 is equal to 5x, and you'd solve it. Here, sorry, I will come back to that screen here in just a moment. Here we have x on the bottom. How do we get rid of that? Like, that's a weird, we don't often see this. What we can do is let's multiply by both sides. Let's multiply it by x. The x's will cancel here, leaving it just with, or you would have, sorry, I'll do it the other way. The x's will cancel out, but I'm going to show it the other way. 35 times x is 35x over x. The x's will cancel out. 7 times x is 7x. So we have minus 35, and these ones cancel out, and 7x. Now it's an easy problem again. We have 7 times x. We have to divide by 7. That's the only way to undo the 7 times is to divide by 7. And divide by 7. So we have x is equal to, what's 35? Negative 35 divided by 7, I think it's negative 5. And indeed, if we have negative 35 divided by negative 5, negatives cancel out. 35 divided by 5 gives us 7, which is the right answer. So they're not that bad, actually, when you start doing them, as long as you know that, okay, it's the same thing. If you got something on the bottom, just multiply it by on the top, but you have to do it on both sides, and then it'll work its way out. This one, probably the easiest way to do this, and the trick to this is, let's get rid of this one on this side first. You could do it the other way, and I can show you as well. But to get rid of it, the minus 4 on this side, because I'm just going to keep, the x terms on this one, which is funny because we're not going to, but hang on to your socks for a second. Or add 4 to both sides. So we have 2 over x is equal to 16. Now we have an x on the bottom. Let's get rid of it by multiplying by times x. Times x. X's cancel out, so you just have 2 on this side is 16x. We have 16 times x. We just want to know what 1x is, so we're going to divide by 16. X is equal to 2 over 16, which is 1 over 8. I can divide the top and bottom by 2. Here, and I'll just rewrite that. X is equal to 2 over 16 divided by 2. We're simplifying here. 1 over 8. All right. I believe that's all the sections I have for you. The quiz is really easy. I'm just going to quickly review that here. Here, plot the following 3 points. Easy peasy. Find the missing value. There is a bit of a trickier question here, and I'll show you that one in a second. But if you have 3, you substitute the x for 3. So you've got 1/3 times 3 minus 6, and you find out what y is. Same with this. Substitute, instead of writing the 12, instead of writing the x, you'd write 12. So 1/3 times 12 minus 6, and you'd solve it. This one's a harder one. And sometimes they do this. It's kind of irregular, but sometimes you'd want to do this. What you're going to do is you're going to replace y with minus 4. So you would have minus 4 is equal to 1/3 x minus 6. You have to solve this one. You know, you're going to keep the x terms on this side of the equals. You're going to add the 6. You have 1/3 x is equal to 2. You have 1/3. You're going to multiply it by the opposite of this, which is times 3 times 3, and you're going to solve that. You'll find out what x is equal to. Here, I'm asking you plot the following 3 linear equations on the same grid. I hope they don't get too confusing. Again, I recommend doing the t-table. If any of you are interested in staying on, I can show you the fast way of graphing these. They don't usually teach it till grade 10, but it's a shame because it's really fast. And you can sort of do this without having to do any calculations. And so I can show that in about 2 minutes. And so do the same thing. Here's one. It's either a horizontal or a vertical line. That's up to you to figure out. And the last one is solving for x. Easy. This looks easy. Oh yeah, there we go. It's divided by 4, so you can multiply by 4. Divided by 2, so you multiply by 2. This one, you're going to get rid of the 4 and then get rid of the 3. Here you have to find a common denominator, multiply, get rid of the fractions. Here I'd get rid of the 7 first and then get rid of the 2. These are just my own thoughts here. And again, this is a pretty basic one. So really not that challenging in terms of what we've just covered today. So again, thanks very much for joining me. Please let me know if I can help in any way. If you're having troubles with quizzes, stay on, ask me questions. I can pull them up. I can do them with you if you want. My interest is that you've been exposed to this material and that you feel somewhat confident going into next grade. Otherwise, what my biggest worry is that you're going to go into grade 10 and you're like, yeah, I never covered any of this and I'm so far behind and it's doom and despair. I don't want that. So I'm happy to just cover over whatever you want at this point. So again, I will go into the chat here. If you have any questions, please just chat away and say, okay, on session number 1, the quiz, I was mixing up on this one. Can you help me out? Or I really need help with this. And the other thing that I want to do is I'm going to go back and I'm going to show you a couple of tricks about graphing, which makes it really easy. So thank you very much. And we'll see you guys soon, or we won't, but have a good summer. Best of luck in math next time. Okay, I'm gonna just, what I would like to do is I'm gonna show you, awesome, yay. Thanks, Sabella. I'm just going to erase these just for a moment. Actually, it's going to be easier if I do it this other way.